Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at Ping and Traceroute Tests. We'll be discussing using Ping to test connectivity. We'll ping the loopback, ping the default gateway, ping a remote host. Then we'll talk about using Traceroute to test the path. We'll look at the round trip time, or RTT. And then finally, we'll take a look at IPv4 time to live and IPv6 hop limit. This episode is part of my series on Introduction to Networks for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Ping is a utility in IP version 4 and IP version 6. It uses an ICMP echo request, and then it receives back an ICMP echo response. This is sort of like, this comes back from the days of old when we used to have submarines, and they would send out a ping to see if anything was out there. This ping sent out a sound wave in the water, and when it went out and hit something solid, that sound would bounce back off and come back to the vessel who sent that out, thereby confirming that something was out there. Same thing happens on today's networks. What we're going to do is we're going to ping a remote device. When that ping works, that confirms that that device is there. That confirms that our network connectivity, we have all of our network configured correctly between where we started and that remote host there. If we don't get a reply, you're going to get some sort of error, and that means something is configured wrong. We need to take a look at our configuration, either on our host here, the local host, or on the remote host, or at the networking in between it. Typically, a lot of times, that first ping, and so right here, switch 1, we did ping and we did an IP address of 192.168.20.2. It sends out 5 pings in this protocol. It sends out 5 echo requests, gets in 5 echo replies. The first one, a lot of times, times out. And that's due to the fact that we have to look up that layer 2 address, whether it's IP version 4 ARP request or IP version 6, that when we send out the neighbor solicitation and neighbor advertisement process. By the time it finds that MAC address, that first echo response times out. But then the other 4 are successful. If you do that same ping again while the MAC addresses or tables are still current, all 5 will work. Same thing with an IP version 6 address. IP version 6, we send out a ping. It sends out on Cisco devices, it sends out 5 echo replies. It was in the MAC address table already. Same process with an IP version 6 address. Notice the syntax. The syntax is the same. We start off with the keyword of ping, put a space in there, and then we put the address in there, whether it's an IP version 4 address like we did in the first example, or an IP version 6 address down here in the second example. It sends out 5 echo requests. It expects 5 echo replies to come back in. One of the first things you should test when you're troubleshooting a network is you should ping your loopback address. Pinging your loopback address is basically talking to yourself. It means that you are sending out an echo reply, you're getting a response back. Here, we use the ping command and we ping our loopback address. And so, once again, you just type in ping in the space and then the loopback address of the device. Now, for IP version 4, it's 127.0.0.1. The loopback for IP version 6 is ::1. You ping those addresses, and what that shows you is IP is properly installed. IP version 4 is properly installed. IP version 6 is properly installed and configured. A lot of times when I type in an address, I'll invert 2 numbers. And with those 2 numbers inverted, everything doesn't work. And so I go back and I ping my loopback address to make sure everything's good, and then I ping my own IP address. When you get a response back from pinging your loopback address, it's saying that IP is properly installed, that the IP protocol is properly installed on the device you're working on. Otherwise, you're going to get an error message that says TCP is not operational on the host. A lot of times, a reboot of the computer will a lot of times fix the issue. So that's one of my first steps in fixing if I can't ping my loopback. Also, make sure that you have your layer 1 connection. Make sure that you have some sort of green or yellow light where you plug in that cable. You have to have that to get a reply back from your loopback address. I hope you're liking this episode on Ping and Traceroute Tests. If you have the time, please leave a comment and let me know what you think about Ping and Traceroute. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Next step would be to ping your default gateway. Pinging your default gateway is probably one of the most common things to check your network connectivity. You ping the default gateway and it shows you that you have network connectivity, that you've configured your IP addresses right, you configured your default gateway right. Also, it shows you that your network to your switches, or your connection to the switch is fine. The connection from the switch to the router is fine. That you have the switch configured properly. You have the router configured properly. It shows that you have all of that configured properly. The reason we ping the default gateway here is because the default gateway is usually always up on your network. It never goes down or up. It's always on. Typically, you never turn off your default gateway. It's the router on your network that typically never gets shut off. If the default gateway doesn't respond, a lot of times what you will do is ping another IP address on your network that you know will respond to verify that your network connectivity is. If the ping still doesn't work, then it's probably local on your PC. If the ping to another remote host works, then you need to look at your default gateway. Once you ping your default gateway, the next step is to go further out. Ping something else on a remote network. If you can successfully ping a host on a remote network, that shows all of your local host information is right. That shows that your router's set up, that routing is set up, and that the rest of your network is working good. Now, a lot of times network administrators, they limit or prohibit the entry of ICMP messages, and that includes the echo request. They block that at their network edge, and that'll come back in your ping window saying is destination host unreachable. Now, that doesn't necessarily mean everything you set up is incorrect. That maybe means that, hey, the network administrator on the far server, on the far network, is blocking that traffic. Traceroute is another tool that we use for troubleshooting. Traceroute tests the past. It's a utility here that lists the hops between your local host and that remote host. Traceroute provides a round trip time for each hop. Each hop means every time it goes through a router and changes network. If a hop fails, you're going to get a message saying, okay, something's not working. Typically, it's an asterisk. That asterisk means, hey, something got lost, something was unreplied, maybe that far network administrator is blocking all ICMP traffic, something is happening. The information to locate it could be problematic because of where this information is being blocked a lot of times. Traceroute uses a function of the either IP version 4 time to live field, or in IP version 6 it uses the hop limit field. And basically each one of those is a maximum number of how many different networks I'm going to go through before I reach my destination. And if that number gets down to 0, we're going to assume that that network is never reachable. We'll also get back an ICMP message saying time exceeded. When you start the traceroute process, the time to live field value will be 1. And what happens is it only can go through one network. It's only going to go to your default gateway. It's going to time out there, and then that way, that default gateway can reply back. And when it replies back, it'll know the address of the device that replied back, and it will know that it was successful. And then once that happens a couple of times on the first hop, then we go to the second hop and we increment that time to live field up by 1. And so that way we can go to the second device. And when it goes through the first device, it gets decremented by 1. When it goes into the second device, it gets to 0, and then we send the message back. And then that message is put into the traceroute table, is saying, okay, this is the IP address, this is how long it took. And we work through that process. The time to field continues to increase until either one of two things are done. Either the destination is reached, in which then the traceroute completes successfully, or there's a limit on how many hops it'll go through. Here in the example, we're doing a traceroute to 192.168.1.2. The first line in our traceroute is going to the default gateway. That's where our time to live is set to 0. And so that goes to the first device, it gets decremented by 1, and then it sends a respawn back, and we fill in the first line. The next one, the time to live is 2. And so we go through our default gateway, decrement it down to 1, then it times out at the second device, that comes back through here. Then for the third line, we increase the time to live to 3. And so we come up through here, we go from 3 to 2 to 1, and then we can reply back with the IP address of that third router. Then we go increase it time to live to 4. And then we start at our local host. It goes all the way through the first router. We go down time to live 3, down to 2, down to 1. And then it's on the destination network. When it reaches the destination right here, the time to live gets decremented down to 0. It gives a timeout echo reply back. It goes all the way through these devices, and it finally fills out the last line in our traceroute table. That last line is our destination address. It successfully completes at that point in time. It was my pleasure to provide you with this wonderful episode on Ping and Traceroute Tests. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on Introduction to Networks. In the bottom right is one of my favorite videos that I picked just for you. Thank you so much for watching this episode of my series on Introduction to Networks for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.